I recently had some YouTube feeds that had Project Valhalla, Java's secret well, it wasn't a secret, I guess, but I didn't know about it. Their Valhalla project that they started in 2014 and have kind of completed in the last few years. And now it's finally reaching my YouTube feed. And I watched it, and there's concepts in there that I don't really know very well. Um, and a lot of new words there like flattening and value objects and then the syntax with the bang operator but I do understand kind of what's going on because it's the way I've been doing things on this new compiler I've been building, and it actually makes a lot of sense of the base concept of what's going on, and we're going to talk about that. We're going to look at it, and we'll see it in the hex editor. So if you're a little confused about what Valhalla is all about, this might clarify a few things. So I'd like to look at here this module I have called a bowl, and this is kind of from a previous video that I've done called object serialization. Modified a little bit, but it's the same thing. And the bowl has, here's the instance data of the bowl. And it has a color, and that's a string object, and my string object is DW string. And I split my string object into DW string or DB string, and the DW string is the Windows equivalent to the UTF-16 because it's 2 bytes per character. So that's my string object. It's a color. It'll be the color of the bowl. And down here I do change the value of the default, which is empty text, and I make it a clear looking bowl. And then this is compile time, so this will be the default data of the bowl, or what I call the master copy of the instance data that all instances are created from. And then the serial is another object in the bowl, and then there's milk and sugar. And this is the default behavior of how these objects are made. It's going to be what Java is calling the flat memory model, where these objects will be just butt up next to each other in memory. They won't be pointers to 4 different objects. It will be inside the instance data of the bowl. Take a leap of faith on that, and hopefully this will make more sense here when you see the project run. Let's go into the entry point of the project called Valhalla. This is my standard entry point. Opens a console window, runs main. We're going to go down here to main. We're going to declare in the data section a bowl. And what that means is it's going to be located in the program space of the Valhalla project. It's going to be, it might be what you call a static object. And so we won't be using the memory manager at all. And that's going to be called new bowl. And then it's going to create another instance of bowl. That's going to be called brown bowl. And then I use a file name object because I need to make a file name because I'm going to save a file to disk. This is because this is still my object serialization example. And I'm going to init the command line, and then I'm going to create my file name, and it's going to be the path of the command line. The file name will be brown bowl. The extension will be serial. Then I'm going to change the colors, the default colors, or default properties of the brown bowl. I'm going to change the color of the bowl from clear to dark brown. I'm going to change the milk to be chocolate milk. I'll change the sugar to be brownish sugar. And I'll change the cereal to be Count Chocula. Then I will take the brown bowl and save it as brownbowl.cereal. Then I'm going to take the new bowl and give a report. This report will be the default value of the new bowl created at compile time. Then I'm going to load into the new bowl my file name, which is brownbowl.serial. And then I'll do the report again. When we run that, we see it says the first report is I first poured the gluten-free flakes into the clear bowl. Then I added some white milk and white granulated sugar. And that's before the load. Then the load happens and I kick the report out again. And now you see it says I first poured the Count Chocula into the dark brown bowl. Then I added some chocolate milk and brown sugar. So after the load, the objects all changed, the properties changed because it loaded in the values from the brown bowl. Press enter. Okay, now we're going to go look in a hex editor of what brownbowl.serial looks like. Okay, this is hex view of brownbowl.serial. Just a file on the disk. It's considered a binary file. That's why you got to look at it with the hex viewer. And you see these top two rows. Each row is 16 bytes. This is kind of my signature of my DW string object. I have my objects putting their name at the top, and it's wasting 32 bytes. So I'll eventually take the names off, but it's really nice in debugging to see the names of the objects printed out on top. This is it's not important for this video, but it's actually a relative pointer that points to the data, and it's 20. So we go 1020, and there's our string buffer. You can read it on the right there. It says dark brown. Then you go down here, and this is all the extra space in the buffer and we see butted up right next to it, and this is what the flat memory model is all about, is that these objects, it's not a pointer, they're just all right next to each other in memory, and the memory was all dumped to disk, so what was in memory is what's on disk, and what's what we're looking at. And this is the next string object. It's got its name at the top, it's got its relative pointer, 1020. There's the data, Count Chocula. That'd be the serial. And we go down to the next object. Another string object, chocolate. I think that might be the milk. Go down to the next DW string object. We got brownish. I think that's the sugar. And there's our 4 string objects. Okay, so that's kind of neat, and that gives you your data locality where the objects are right next to each other in memory, and that increases your probability of cache hits, which makes things a lot faster. And if the more bundling you can do with your objects, and by the way, when you bundle objects, that's literally object composition, which is I like object composition. That's all I can say about that. I don't even want to even start talking about inheritance or anything right now. So let's go to the bowl again. And I said this is the default behavior, but sometimes you want a pointer sometimes, because that's just what you want sometimes. You don't want it to be the flat memory model. Let's say maybe there's times where you're not going to put sugar in it, and you're just going to not even instantiate the sugar object at all. Sometimes make it kind of an optional object. Sometimes you want to do that. And so if it's not, if someone isn't using sugar, you don't want to take up space. So you can make sugar a pointer. Now, of course, it's going to upset a few things here, but we're going to ignore that. We're going to come back here to the project here. Now, let's just let's take a look at these things. Let's do a compare of brown bowl dot variables dot sugar. dot. IntelliSense now has address pointed at. It wasn't there before because it wasn't a pointer before. It was part of the flat memory model. But now, since we declared a pointer, now we can look at the address it's pointed at. Now, the default, when you don't have it instantiate anything, is that it's 0. The pointer is 0, which I believe is what all these other languages call a null pointer. Could be wrong. Go ahead and correct me if I need to, but I've always considered a 0 pointer to be a null pointer. So now the sugar has that. Let's take a look at brown bowl dot variables dot serial. Notice that serial doesn't have the address pointed at because it's the flat memory model. It's not a pointer, so you don't get that in the drop down. So in my opinion, this whole concept of the flat memory model for object-oriented programming is actually a huge upgrade. It's like OOP 2.0 in my opinion. It gives you your data locality, which gives huge performance increase boosts. So, actually, it should have been this way the whole time. This whole thing of object composition and being all pointers, it was never a good idea. But you know what? You never get things perfect your first time, I guess. And so I think this is kind of a big deal. And Java did it. So kudos to Java. I don't know. That's all I got. Thanks for watching.